The year was 1940, and a terrifying silence had fallen over the skies of China, soon to spread across the vast expanse of the Pacific Ocean. For years, the world's aviation powers, Britain, the United States, and Germany, believed they held the monopoly on air superiority. They trusted in their heavy engines, their thick armor, and their established doctrines of aerial warfare. But in the East, a phantom was rising, a machine so agile and so deadly that for the first 2 years of the war, it would seem invincible. It was a ghost that could turn on a dime, climb like a rocket, and vanish into the clouds before an enemy pilot could even bring his guns to bear. This was the Mitsubishi A6M, known to the Japanese Navy as the Type 0 carrier-based fighter, and known to the terrified Allied pilots simply as the Zero. To understand the sheer shock the Zero delivered to the Allies, one must look at the state of aviation at the time. The Americans were flying the P-40 Warhawk and the F4F Wildcat, planes that were rugged, certainly, but heavy and sluggish by comparison. The British were reliant on the Hurricane and the Spitfire in Europe, but their Pacific fleet was woefully under-equipped. When reports first trickled in from the Sino-Japanese War of a new Japanese fighter that could outmaneuver anything in the sky, Western intelligence dismissed them. Racism and arrogance blinded military planners in Washington and London. They believed the Japanese were incapable of building a world-class fighter, assuming their aircraft were merely inferior copies of Western designs. They were wrong. Dead wrong. When the attack on Pearl Harbor shattered the American peace on December 7, 1941, it wasn't just the devastation of the battleships that signaled a new era. It was the silver-white fighters sweeping low over Oahu. They danced through the anti-aircraft fire with an elegance that defied physics. In the months that followed, as the Japanese Empire expanded into the Philippines, the Dutch East Indies, and New Guinea, the Zero became the Grim Reaper of the Pacific. Allied pilots would report engaging the enemy, only to find the Zero had looped behind them in seconds. It was a machine that felt less like a piece of technology and more like an extension of the pilot's will. The psychological impact was devastating. A phenomenon known as Zero fever began to spread among Allied squadrons. It was a mixture of awe and paralyzing fear. Rookie pilots were told never to dogfight a Zero, never to try and turn with it. The standing order was to dive, run, and pray you had enough speed to get away. The Zero possessed a range that was unheard of at the time, allowing it to strike targets thousands of miles from its base, appearing in skies where the Allies felt safe, shattering their sense of security. It ruled the air not just with gunpowder, but with the terrifying reputation of invincibility. However, this dominance was built on a specific, ruthless philosophy. The Zero was a samurai sword, incredibly sharp, fast, and lethal, but also brittle. It was designed for the attack, for the swift kill. It was not designed to take a hit. In those early years, this weakness didn't matter because no one could hit it. The skies belonged to the Empire of the Sun. The American Navy, reeling from its losses, knew that their current aircraft were simply placeholders. They were fighting a losing battle of attrition, holding the line with grit and courage against a technologically superior foe. But war is a driver of rapid evolution. While the Zero pilots reveled in their victories, believing their aircraft to be the pinnacle of aviation engineering, a sleeping giant was waking up back in the United States. In the factories of Grumman, on Long Island, engineers were looking at the reports of the Zero's performance. They weren't just looking to match it, they were looking to break it. The era of the Zero's reign was absolute, but the seeds of its destruction were already being drawn on blueprints. The story of the Pacific Air War is often told as a game of numbers, but it was truly a duel of design philosophies. The Zero represented the Japanese ideal of spirit and agility, sacrificing protection for performance. The American response would represent the Western ideal of power, survivability, and overwhelming force. The Zero had set the standard, but a new predator was being born in the ironworks of America. A predator that wouldn't just fight the Zero, but would hunt it down and sweep it from the sky. As 1942 dragged on, the Zero continued to carve its legend across the ocean. From the Coral Sea to Midway, even in defeat, the Japanese fighter remained the superior machine in a one-on-one fight. Allied pilots respected it, feared it, and died by it. But the clock was ticking. The invincible legacy of the Zero was about to collide with a blue beast designed specifically to kill it. This is the story of how the F6F Hellcat rose from the factory floor to shatter the myth of the Zero and turn the tide of the greatest air war in history. The story of the Zero is intrinsically linked to the vision of one man, Jiro Horikoshi. Born in rural Japan in 1903, Horikoshi was a quiet, unassuming engineer with a fierce intellect and an unwavering dedication to aviation. He joined Mitsubishi Heavy Industries in 1927, fresh out of the University of Tokyo's prestigious Faculty of Engineering. From the outset, Horikoshi displayed a radical approach to aircraft design, constantly pushing the boundaries of what was thought possible. By the mid-1930s, as Japan's imperial ambitions grew, the need for a superior carrier-based fighter became paramount. The existing Japanese naval fighters, while competent, were quickly becoming obsolete in the face of rapidly advancing European and American designs. In 1937, the Imperial Japanese Navy issued a specification for a new fighter, the 12 that was nothing short of an impossible dream. They demanded a range of 2,000 nautical miles, a top speed of 310 miles per hour, and the ability to climb to 9,800 feet in just 3.5 minutes. Crucially, it had to be extremely agile and capable of operating from aircraft carriers. These demands were considered ludicrous by contemporary aircraft designers around the world. No existing fighter could meet even half of these requirements. Most engineers would have dismissed the specification as fantasy, but Horikoshi saw it as a challenge to invent, to innovate, and to break free from conventional thinking. Horikoshi understood that to achieve the Navy specifications, every single ounce of weight had to be scrutinized, and every aerodynamic drag source had to be minimized. He faced immense pressure from the military, who wanted an aircraft yesterday, and skepticism from his peers, who believed he was chasing a ghost. Yet, driven by a deep sense of national duty and an almost artistic pursuit of aerodynamic perfection, he began to design. His team worked relentlessly, often late into the night, sketching designs, calculating stress points, and experimenting with new materials. The result was a sleek, elegant airframe that represented a significant leap forward in aviation engineering. The innovations were numerous. Horikoshi opted for a revolutionary flush-riveted construction and a sophisticated low-wing cantilever design, both highly advanced for the era. He pushed for the use of a new, top-secret aluminum alloy known as T7178, which was lighter and stronger than conventional duralumin, allowing for a lighter airframe without compromising structural integrity, or so it was thought. The engine, the Nakajima Sakai 12, was meticulously integrated into the design, providing the power-to-weight ratio needed for exceptional climb rates and speed. Every curve, every joint, Every surface was honed for maximum aerodynamic efficiency. The prototypes, starting with the A6M1 in 1939, immediately demonstrated Horikoshi's genius. During flight tests, the aircraft not only met but often exceeded the Navy's seemingly impossible specifications. Its maneuverability was unparalleled, its range astonishing. Pilots reported that it was an absolute joy to fly, responding instantly to controls, feeling like an extension of their own bodies. This was the moment the legend of the Zero began, not on a battlefield, but on a test flight, soaring through the clear Japanese skies. It was the culmination of Horikoshi's audacious vision, defying the norms of aviation design. However, Horikoshi's brilliance came at a cost, a profound and ultimately fatal compromise. To achieve the extraordinary performance demanded by the Navy, he was forced to make a series of crucial decisions regarding protection. Weight was the enemy, and anything that added weight without directly contributing to speed or maneuverability was deemed expendable. This meant no self-sealing fuel tanks, very little armor plating for the pilot, and a minimalist structural design that, while incredibly light, was also inherently fragile. In the feverish pursuit of their impossible dream, the vulnerabilities of the Zero were largely overlooked or deemed acceptable sacrifices by the Japanese military leadership. They believed that superior skill and an invincible aircraft would negate the need for passive protection. This philosophical difference, between offense at all costs and a balance of offense and defense, would define the air war in the Pacific. Jiro Horikoshi had created a masterpiece, but it was a glass sword, magnificent to behold and devastating in attack, yet tragically vulnerable when struck. The Zero's extraordinary performance came from a deliberate and often brutal design philosophy: extreme weight saving. Every component was evaluated, not just for its function, but for its mass. Armor plating, a standard feature in Western fighters, was completely absent in the early Zero models. The pilot sat exposed, with no steel plate behind him to protect against incoming fire. Fuel tanks, which in Allied aircraft were lined with self-sealing rubber to prevent catastrophic fires, were simply bare aluminum in the Zero. The thinking was simple: if the Zero was so agile, it wouldn't get hit. This was the weight of paper approach: light as paper, as easily torn. This philosophical choice was rooted in Japan's pre-war experience and strategic priorities. Having observed European aerial combat doctrines, Japanese naval strategists emphasized offensive striking power and maneuverability above all else. They reasoned that a highly agile aircraft could evade enemy fire, rendering heavy armor unnecessary. Furthermore, the ability to project air power across vast distances of the Pacific was critical. Range meant lighter fuel loads or fewer return trips to carriers, which directly translated to less weight. So, speed, climb, range, and agility became the gods of Zero design, and armor became the ultimate sacrifice at their altar. The consequences of this decision were stark. When the Zero was hit, it often burned catastrophically. The unprotected fuel tanks, even from a single bullet, could erupt into an inferno. Allied pilots quickly learned that if they could get even a brief shot into a Zero, it was likely to explode or burst into flames. This vulnerability was compounded by the aircraft's lightweight construction. While the T-7178 aluminum alloy was strong for its weight, it was not designed to withstand high-caliber machine gun rounds or cannon shells. Even glancing blows could severely compromise the airframe, often tearing off control surfaces or leading to structural failure. Initially, This vulnerability was masked by the Zero's unmatched performance. In the hands of highly trained, veteran Japanese pilots, many of whom had honed their skills in the skies over China, the Zero was indeed difficult to hit. These pilots were masters of evasive maneuvers, exploiting every ounce of their aircraft's agility to dance around incoming fire. Their skill, combined with the Zero's superior performance against early Allied aircraft, created an illusion of invincibility. It fostered a dangerous overconfidence within the Japanese military, reinforcing the belief that armor was indeed superfluous. However, as the war progressed, this flaw became increasingly apparent and devastating. The quality of Japanese pilot training, though initially superior, began to decline as experienced pilots were lost and replaced by hastily trained recruits. These new pilots lacked the finesse to consistently evade incoming fire. Simultaneously, Allied tactics evolved. Instead of trying to turn with the Zero, American pilots developed boom and zoom strategies, diving from altitude, firing, and then extending away, refusing to engage in a dogfight where the Zero held the advantage. This negated the Zero's maneuverability and directly exploited its fragility. The cost in human lives was immense. Japanese pilots, often fanatically devoted to their emperor and country, were strapped into flying fuel tanks. A single good burst from an American .50 caliber machine gun could turn their aircraft into a fiery tomb. The emotional toll on the surviving pilots, watching their comrades explode in the sky, was severe. This wasn't just a design oversight. It was a fundamental difference in how human life was valued and protected in wartime aircraft design between the two belligerents. In retrospect, Jiro Horikoshi and his team were operating under stringent requirements and resource limitations. The Japanese industrial base could not churn out heavy, powerful engines like the Americans, nor could they afford to waste precious materials on non-essential protection. The Zero was a product of its time, its nation's strategic priorities, and its available technology. It was a marvel of aeronautical engineering for its performance, but its fatal flaw, the weight of paper, would ultimately be its undoing when confronted by a new breed of American fighters built on an entirely different philosophy of combat. The attack on Pearl Harbor on December 7, 1941, was a devastating blow, but it was merely the opening act of a larger, more terrifying drama unfolding across the Pacific. As Japanese forces swept through Southeast Asia and the Pacific Islands, the Zero became the harbinger of their air superiority. For the Allied pilots who faced it in the early months of the war, the Zero was nothing short of a nightmare. It wasn't just a superior aircraft. It felt like an alien presence, capable of maneuvers that defied belief, turning what should have been an equal dogfight into a desperate struggle for survival. The primary American naval fighter at the time was the Grumman F6F Wildcat. It was a sturdy, rugged machine, built to take punishment, but it was slower, less agile, and possessed a lower climb rate than the Zero. In a turning fight, the Wildcat was hopelessly outclassed. Pilots quickly learned that trying to match a Zero's turn was suicide. They would find themselves with a Zero on their tail, its twin 20mm cannons and two 7.7mm machine guns spitting fire, almost before they registered the threat. Many a young, inexperienced pilot made this fatal mistake, becoming another statistic in the Zero's grim tally. The P-40 Warhawk, the workhorse of the Army Air Forces in the Pacific, fared little better. While a decent fighter in its own right, especially at higher altitudes, it was no match for the Zero's low-altitude agility. American pilots found their P-40s struggling to keep up, often being picked off one by the more maneuverable Japanese fighters. The famous Flying Tigers in China, led by Claire Chennault, developed innovative tactics to counter the Zero, such as slash-and-run attacks and diving passes. These tactics were effective, but they conceded air superiority in a sustained dogfight and required extreme discipline and excellent situational awareness. The sheer range of the Zero further amplified the nightmare. It could operate from aircraft carriers or island bases thousands of miles from the front lines, appearing over targets where the Allies had no expectation of encountering high-performance fighters. This enabled deep penetration raids and unchallenged air cover for Japanese ground and naval forces, contributing significantly to their rapid territorial gains. The psychological toll was immense. Knowing that a Zero could appear almost anywhere, anytime, flying faster and turning tighter than anything they possessed, created an atmosphere of constant anxiety and dread among Allied aircrews. Reports from combat zones painted a grim picture. The Japanese fighter is far superior to anything we have, cannot turn with the Zero, outclimbs and outruns us at every altitude. These reports, initially dismissed by armchair strategists back home, quickly became undeniable. The casualty rates for Allied air forces were alarmingly high. For every Japanese aircraft lost, the Allies were losing 3, 4, or even 5. The Zero had established a reign of terror, a period of undisputed dominance that threatened to cripple Allied efforts in the Pacific. This nightmare wasn't confined to dogfights. The Zero's presence ensured Japanese control of the skies, which had direct and devastating consequences for ground troops and naval vessels. Unopposed Japanese bombers, escorted by Zeros, wrought havoc on Allied bases, supply lines, and convoys. Without air cover, naval battles became even more perilous, and island garrisons were vulnerable to incessant bombing and strafing runs. The Zero wasn't just winning air battles, it was enabling the entire Japanese war machine to roll across the Pacific. Yet, even in this darkest hour, there were glimmers of hope and lessons learned. Pilots like Joe Foss and Butch O'Hare, flying Wildcats, developed personal tactics to survive and even score victories against the Zero, often by using the Wildcat's robust construction to their advantage or by exploiting a Zero's overeagerness. Every encounter, every harrowing escape, provided vital intelligence. The Allies were slowly gathering data, understanding the Zero's strengths and, crucially, its weaknesses. The nightmare was real, but it was also a powerful catalyst. It was forcing the Americans to innovate, to adapt, and to build a fighter that could not only survive the Zero but utterly shatter its terrifying legacy. The ironworks back home were listening. While the Zero was carving a swathe of destruction across the Pacific, a different kind of war was being waged back in the United States. In the bustling factories of Grumman Aircraft Engineering Corporation on Long Island, New York, a sense of grim determination had settled over the engineers and workers. Known colloquially as the Grumman Ironworks for their reputation for building rugged, almost indestructible aircraft, they were acutely aware of the reports coming out of the Pacific. Their F4F Wildcat was proving to be a valiant fighter, but it was clear it was outmatched in agility by the Zero. The U.S. Navy needed something new, something that could not just compete, but dominate. Grumman's philosophy was born from its experience building planes for carrier operations. They understood the brutal realities of naval aviation, hard landings, corrosive salt spray, and the need for aircraft that could take a beating and still get their pilots home. This philosophy stood in stark contrast to the Zero's delicate design. Grumman's engineers, led by the legendary Leroy Grumman, Jake Swerbel, and Bill Schwendler, didn't aim for sleek elegance. They aimed for brute force and unparalleled survivability. They began design work on what would become the F6F Hellcat even before Pearl Harbor, but the early combat reports from the Pacific rapidly accelerated their efforts and dramatically influenced its final form. While the Zero's designer, Jiro Horikoshi, aimed for aerodynamic purity through lightness, Grumman aimed for overwhelming combat capability through strength and firepower. The Hellcat was built like a tank. Its construction featured robust, heavy-gauge aluminum, reinforced spars, and a wide-track landing gear that could absorb the shock of carrier landings. Crucially, it incorporated extensive armor plating for the pilot, often over 200 pounds of it, a stark contrast to the Zero's unprotected cockpit. Self-sealing fuel tanks, another feature missing from the Zero, were standard on the Hellcat, dramatically reducing the risk of catastrophic fires from enemy hits. The urgency at the ironworks was palpable. Teams worked around the clock, fueled by patriotism and a desire to provide their fighting men with the best possible tools. The design process was iterative and responsive. As more intelligence came in about the Zero, designers refined the Hellcat's wings, control surfaces, and armament. They integrated 6.50 caliber Browning machine guns into the wings, providing a devastating hail of fire that could rip apart even the most robust enemy aircraft, let alone the fragile Zero. This emphasis on heavy armament was another key difference from the lighter weaponry of the Japanese fighter. The commitment of Grumman was not just to build a better plane, but to build it faster than anyone thought possible. They streamlined production, perfected assembly lines, and maximized output. From drawing board to first flight, the Hellcat's development was incredibly swift, a testament to American industrial might and the sheer determination of the Grumman workforce. By early 1943, the first production F6F Hellcats began rolling off the assembly lines, ready to be delivered to the Navy. These machines were more than just aircraft. They were a defiant answer to the Zero, a symbol of American resilience, and a promise that the balance of power in the Pacific was about to shift dramatically. The stage was set for the showdown. While Grumman engineers were laboring to design the Hellcat, an extraordinary intelligence coup occurred in the Aleutian Islands, a remote and desolate chain stretching from Alaska. On June 4, 1942, during the Battle of Midway, a Japanese Zero pilot named Tadayoshi Koga launched from the carrier Ryujo to attack Dutch Harbor. His Zero, a Model A6M was hit by ground fire, damaging its oil line. Koga attempted an emergency landing on Akutan Island, a designated Japanese recovery point. He overshot his landing, flipping the aircraft onto its back in a soft, muddy bog. Tragically, Koga was killed, likely from a broken neck upon impact, but his Zero remained remarkably intact. Days later, on July 10th, an American PBY Catalina patrol plane spotted the downed Zero. The discovery sent immediate ripples of excitement through Allied intelligence. Here was an almost perfectly preserved Zero, the aircraft that had been terrorizing their pilots, available for meticulous study. Previous attempts to examine Zero wreckage had yielded little, as most crashed planes were too fragmented or underwater. This was different. This was the holy grail of enemy intelligence, a nearly complete, undamaged specimen. A recovery team was quickly dispatched. Operating in the harsh, foggy conditions of the Aleutians, they meticulously righted the aircraft, patched its wings, and managed to float it out of the bog. The Zero was then loaded onto a barge and transported to the nearby naval air station at Dutch Harbor. From there, It began a top-secret journey to Naval Air Station North Island in San Diego, where it would be carefully reassembled and put through a battery of tests. This captured Zero, soon nicknamed the Akutan Zero or Koga Zero, represented an unprecedented opportunity to understand the enemy's most feared weapon. The examination of the Akutan Zero was a watershed moment for Allied aircraft design and tactics. American engineers and test pilots swarmed over the aircraft, dissecting every aspect of its construction and performance. They confirmed the Zero's extreme lightness and the complete lack of pilot armor and self-sealing fuel tanks. They studied its control systems, its landing gear, its engine, and its armament. This first-hand knowledge debunked many myths and confirmed painful truths. The Zero was indeed incredibly agile and lightweight, but it was also fragile and highly susceptible to fire. Test pilot Lieutenant Commander Eddie R. Sanders was tasked with test flying the captured Zero. His reports were invaluable. He confirmed its exceptional maneuverability, its rapid roll rate, and its impressive climb. However, he also identified its critical weaknesses. Its carburetor engine would cut out under negative G-forces, diving with a push of the stick, its dive speed was limited, and its airframe was indeed fragile. Sanders also discovered that while the Zero was superb at low speeds, its control surfaces stiffened dramatically at higher speeds, making it much less maneuverable. The intelligence gleaned from the Akutan Zero directly influenced the final design and tactical deployment of the F6F Hellcat. It validated Grumman's heavy fighter approach, confirming that an armored, powerful aircraft with self-sealing tanks was the correct counter. Crucially, it informed Allied pilots about the Zero-specific vulnerabilities and how to exploit them. They now knew why the Zero was so maneuverable: lightness, large wing area, and where its Achilles heel lay: fragility, high-speed control issues, engine limitations. This intelligence was invaluable, turning the Zero from a terrifying unknown into a quantifiable enemy with exploitable weaknesses. The Akutan Zero didn't just provide data. It provided the key to defeating the Phantom of the Pacific. The F6F Hellcat was not designed to merely match the Zero. It was designed to kill it. The profound differences between the two aircraft stemmed from fundamentally opposing design philosophies and the intelligence gathered from combat experience, culminating in the analysis of the Akutan Zero. Where Jiro Horikoshi had designed a razor-sharp, lightweight rapier, Grumman created a blunt, powerful sledgehammer. This comparison isn't merely poetic. It reflects every aspect of their engineering. Let's begin with power. The Zero was powered by the Nakajima Sakai 12 engine, typically producing around 950 horsepower. It was efficient and contributed to the Zero's fantastic range and climb. The Hellcat, by contrast, boasted the monstrous 2,000 horsepower Pratt & Whitney R2800 Double Wasp. This engine gave the Hellcat a huge advantage in speed, climb rate, and diving performance. It could accelerate away from a Zero in a dive, a crucial escape maneuver for Allied pilots. This power difference was central to the Hellcat strategy: hit hard and get out fast. Next, armament. The Zero typically carried two 20mm cannons and two 7.7mm machine guns. While the 20mm cannons were potent, they had limited ammunition. The Hellcat, on the other hand, was armed with 6.50 caliber Browning M2 machine guns. While smaller in caliber, their sheer number, high rate of fire, and generous ammunition supply meant the Hellcat could unleash a devastating stream of lead. A single burst from a Hellcat was often enough to rip apart the lightly constructed Zero, turning it into a flaming wreck. Protection was where the philosophies truly diverged. The Zero, as we've discussed, had virtually no pilot armor and unprotected fuel tanks. This made it vulnerable to even light machine gun fire. The Hellcat was built with survivability in mind. It featured 210 pounds of armor plating around the cockpit, a bulletproof windscreen, and, critically, self-sealing fuel tanks. These tanks were designed to automatically seal small holes, preventing fuel leaks and subsequent fires. Hellcat pilots often returned to their carriers with their aircraft riddled with bullet holes, but still flying, a testament to its robust construction. This allowed pilots to press attacks and survive hits that would have instantly destroyed a Zero. Maneuverability was the Zero's undisputed forte at low to medium speeds. Its large wing area and light weight allowed it to turn on a dime, outturning any early Allied fighter. The Hellcat was heavier and had a smaller wing loading, making it less agile in a slow-speed dogfight. However, the Akutan Zero tests revealed that the Zero's control stiffened considerably at high speeds, while the Hellcat remained highly controllable. The Hellcat was also significantly faster in a dive, thanks to its powerful engine and strong airframe. This meant Hellcat pilots could use boom and zoom tactics, dive, shoot, and speed away, refusing to engage in the Zero's preferred slow-speed turning fight. The sheer ruggedness of the Hellcat was another key factor. It was designed to withstand the rigors of carrier operations and the stresses of combat. It could take significant battle damage and still bring its pilot home, whereas the fragile Zero would often disintegrate or burst into flames after a few hits. This resilience built confidence in Allied pilots, allowing them to fight more aggressively. In essence, the Hellcat was designed to counter every strength of the Zero and exploit every weakness. It traded the Zero's delicate agility for raw power, heavy firepower, and unparalleled survivability. This wasn't just a new aircraft. It was a new doctrine of aerial combat that was about to shatter the legend of the Phantom of the Pacific. By 1943, the American industrial machine was not just churning out aircraft, it was producing pilots. But a plane, no matter how advanced, is only as good as the hands on the stick. The introduction of the F6F Hellcat coincided with a massive overhaul in how the United States Navy trained its aviators. The desperation of 1942 was gone. In its place was a calculated, methodical system designed to produce not just flyers, but aerial killers. The ironworks had built the sword, but the Navy had to forge the samurai to wield it, albeit a samurai who flew with slide rules and radio discipline rather than just spirit. The training pipeline for Hellcat pilots was rigorous and exhaustive. Unlike the Japanese system, which kept its best aces on the front lines until they were inevitably killed, the U.S. Navy rotated its veterans home. Men who had survived the brutal dogfights of the Coral Sea and Midway returned to training bases in Florida, Texas, and California. There, they passed on their hard-won knowledge to fresh recruits. They taught the rookies the specific traits of the Zero, its tendency to drift in a high-speed roll, its inability to dive effectively, and its deadly turning radius. This institutional memory created a learning curve that accelerated with every graduating class. A critical component of this new doctrine was the Thatch Wave, a tactical maneuver developed by John Thatch. While invented for the slower Wildcat, it became devastatingly effective when executed by the faster Hellcat. The maneuver required two American fighters to fly in a weaving pattern, covering each other's blind spots. If a Zero latched onto the tail of one Hellcat, the other would cross over, bringing its guns to bear on the pursuer. It turned the Zero's agility against itself, baiting Japanese pilots into a trap where their focus on a single target made them vulnerable to a wingman they never saw coming. In the cockpits of the new F6F Hellcats, pilots found a machine that was forgiving yet powerful. It was a stable gun platform, crucial for rookie pilots who needed to land hits without fighting the aircraft's aerodynamics. The Hellcat's wide landing gear also made carrier operations, often the most dangerous part of a mission, significantly safer than in previous aircraft. This reduced non-combat accidents and ensured that more pilots and planes actually made it to the fight. The confidence this inspired cannot be overstated. Pilots knew they were flying a tank that could punch like a heavyweight. Simultaneously, the intelligence from the Aviation Zero was disseminated into training manuals. Pilots were taught a simple mantra: speed is life. They learned to keep their energy high, to avoid slow turning fights, and to utilize the Hellcat's superior diving speed. They were drilled on the boom and zoom tactic, climbing high, diving on a Japanese formation, firing a devastating burst, and then using the momentum to zoom back up to altitude, out of reach of the climbing Zeros. It was a disciplined, scientific approach to warfare that stripped the Zero of its advantages. The contrast with the enemy was stark. By late 1943, Japan was running out of experienced pilots. Their training programs were being shortened to rush bodies to the front. The men facing the new Hellcat pilots were often barely trained, flying aircraft that hadn't evolved significantly since Pearl Harbor. The Americans, meanwhile, were arriving in theater with hundreds of flight hours, flying a brand new superior fighter, and armed with the specific knowledge of how to kill their enemy. The atmosphere on the carrier decks changed. The apprehension of 1942, the fear of the invincible Zero, was replaced by a predatory anticipation. The new Hellcat squadrons, painted in sea blue camouflage, looked different. They sounded different, with the deep, throaty roar of the R2800 engines vibrating through the steel decks. These weren't desperate defenders holding the line anymore. They were hunters, trained, equipped, and eager to test their new claws against the phantom that had haunted the Pacific for 2 long years. The F6F Hellcat made its combat debut on August 31, 1943, in a raid over Marcus Island. It was a probing attack, a testing of the waters, but the results were immediate and electrifying. For the Japanese pilots stationed on the island, the sight of the new American fighters must have been confusing. At a distance, the Hellcat bore a family resemblance to the older Wildcat, stubby, angular, and blue. A Japanese pilot might have felt a surge of confidence, thinking he was about to engage an inferior, sluggish opponent. He would have banked his Zero, expecting to easily outmaneuver the American. That assumption was the last mistake many of them would ever make. As the Zeros engaged, they found that these Wildcats didn't behave like Wildcats at all. They climbed with terrifying speed. They closed the distance in seconds. When the Zeros tried to loop and turn, expecting the Americans to fall behind, the Hellcats powered through the maneuvers, their massive engines screaming. The shock was absolute. The Americans weren't just keeping up, they were dictating the engagement. On October 5, 1943, over Wake Island, the Hellcat truly announced its arrival. A massive force of Hellcats swept in, engaging the Japanese garrison's air defenses. In the ensuing dogfights, the Hellcats destroyed 22 enemy aircraft while losing only 12 of their own, a ratio that would only improve as tactics were refined. The radio chatter from Japanese pilots captured the panic. Enemy fighter is fast. Cannot shake him. The myth of the Zero's invincibility wasn't just cracking. It was being shattered by .50 caliber rounds. The psychological impact of these early encounters was profound. For American pilots, the realization that they finally had the superior machine was a massive morale booster. Stories circulated through the mess halls of Hellcats taking 20mm cannon hits and flying home, of pilots diving at speeds that would rip the wings off a Zero, of the sheer destructive power of the 6 machine guns. The Zero fever that had plagued the early war vanished, replaced by a cool, professional confidence. The hunter had become the hunted. For the Japanese, it was a catastrophe. Their entire air doctrine relied on the superiority of the Zero and the skill of their pilots. Now, both were being negated. The Hellcat could dictate where and when the fight happened. If a Hellcat pilot found himself at a disadvantage, he could simply dive away. The Zero could not catch him. If a Zero pilot made a mistake, the Hellcat had the speed to close in and finish him. The margin for error for Japanese pilots, already slim due to their lack of armor, evaporated completely. As the U.S. Navy pushed into the Gilbert and Marshall Islands in late 1943, the Hellcat led the way. Over Tarawa and Marken, Hellcats swept the skies clear, allowing dive bombers and torpedo planes to work unmolested. The Japanese air forces in the region were decimated. The Zero, once the phantom that struck from nowhere, was now being swatted from the sky with brutal efficiency. The skies above the Pacific were turning into a killing field, and the Hellcat was the executioner. By the end of 1943, the statistics were telling a grim story for the Empire. The kill ratios were skewing heavily in favor of the U.S. Navy. The F6F had proven itself not just as a carrier fighter, but as an air superiority weapon. It could loiter over targets, protect the fleet, and hunt down enemy interceptors. The debut of the Hellcat marked the end of the balance of power in the air war. From this point on, it was no longer a fair fight. It was a systematic dismantling of Japanese air power, carried out by a machine built for exactly that purpose. June 19, 1944. The Battle of the Philippine Sea. This day would go down in history not as a battle, but as a slaughter, a testament to the total dominance of the F6F Hellcat. The Japanese Navy, desperate to halt the American advance toward Saipan, committed the bulk of their remaining carrier air power. Vice Admiral Jisaburo Azawa launched massive waves of aircraft, hundreds of Zeros, dive bombers, and torpedo planes, intending to smash the U.S. Fifth Fleet. It was a gamble, a massive throw of the dice, relying on the hope that the spirit of the samurai could overcome the weight of American steel. But the Americans were ready. Their radar picked up the incoming Japanese waves nearly 150 miles out. The call went out across the decks of the American carriers, "Man your planes." Hundreds of Hellcats roared to life, launching into the bright Pacific sky to intercept the enemy long before they could reach the ships. What followed was the greatest carrier battle in history, and the single most one-sided air engagement of the entire war. As the Japanese formations approached, they were met by a solid wall of Hellcats. The Japanese pilots, many of them fresh recruits with barely enough training to take off and land, were flying into a meat grinder. They were disorganized, flying predictable patterns, and piloting Zeros that were now hopelessly obsolete against the upgraded Hellcats. The American pilots, veterans with hundreds of hours of training and combat experience, dove into the enemy formations with ruthless efficiency. The sky over the Philippine Sea became a chaotic canvas of contrails, smoke, and fire. It was described by one American pilot as like an old-time turkey shoot down home. The phrase stuck. The Great Marianas Turkey Shoot was a systematic destruction of the Imperial Japanese Naval Air Service. Hellcats tore through the Japanese ranks, slashing attacks that sent Zeros spinning into the ocean in flames. The discrepancy in technology was glaring. The Hellcats could absorb punishment and keep fighting. The Zeros, true to their design, disintegrated under the heavy .50 caliber fire. The numbers were staggering. By the end of the day, the United States had lost fewer than 30 aircraft. The Japanese had lost over 300. It was a massacre. The cream of the remaining Japanese naval aviation was wiped out in a single afternoon. Squadrons were annihilated. Carriers were left with empty hangars, their striking power erased. The Zero, the plane that had once ruled the Pacific, was reduced to a helpless target, unable to defend itself, let alone attack the American fleet. The battle wasn't just about the pilots. It was the vindication of the design philosophy. The Hellcat's ruggedness meant that pilots who made mistakes survived to fight again. Its fuel capacity allowed them to stay in the fight longer. Its ammunition load allowed them to engage multiple targets. The Zero, designed for a short, sharp war of maneuver, was utterly unsuited for this attrition-style mass combat. The weight of paper had finally collapsed under the weight of American industry. The victory at the Philippine Sea broke the back of Japanese naval aviation. They would never recover. The carriers that survived the battle retreated, but they were hollow shells, vessels without aircraft or pilots to fly them. The Hellcat had done more than just win a battle. It had effectively ended the air war at sea. The road to Tokyo was now open, and the skies above it belonged to the Grumman F6F. But as the conventional air war ended, a darker, more desperate chapter was about to begin. The Japanese, realizing they could no longer compete in traditional combat, would turn to a tactic born of sheer desperation and fanaticism. The Hellcat had defeated the Zero as a fighter, but it was about to face the Zero as a guided missile. The era of the kamikaze was approaching. By late 1944, the air war in the Pacific had undergone a grotesque transformation. The classic dogfights, the swirling, elegant dances of death between the Zero and the Wildcat, were gone. Japan, its navy shattered and its experienced pilot corps decimated, turned to a tactic born of sheer, nihilistic desperation, the kamikaze. The divine wind. The logic was brutal but mathematically sound in the eyes of the Japanese command. If a pilot could not survive a dogfight against a Hellcat to drop a bomb, then the pilot and the plane became the bomb. The Mitsubishi Zero, once the symbol of aerial supremacy and grace, was stripped of its soul and converted into a manned-guided missile. For the pilots of the F6F Hellcat, the mission profile changed overnight. They were no longer hunting for sport or air superiority in the traditional sense. They were the last line of defense, the blue wall standing between the fleet and annihilation. The terrifying reality of the kamikaze tactic was that it negated the skill gap. A novice pilot didn't need to know how to dogfight. He just needed to know how to fly a plane into a ship. The Zero, with its long range and ability to carry a heavy bomb load, became the primary weapon of this suicide corps. The psychological strain on the American Navy was immense. Sailors on deck would watch the radar screens, seeing the bogies closing in, knowing that each blip represented a human being intent on dying to kill them. For the Hellcat pilots, the pressure was excruciating. Intercepting a kamikaze required a different kind of flying. It wasn't enough to just damage the enemy plane. You had to disintegrate it. A damaged Zero could still crash into a flight deck. Hellcat pilots had to fly directly into the murderous wall of their own fleet's anti-aircraft fire to chase down the diving Zeros. They had to pour streams of .50 caliber fire into the cockpit or the engine, trying to saw the wing off or explode the pilot before he could complete his final dive. This period saw the Hellcat operating at its absolute peak of efficiency. The Big Blue Blanket strategy was implemented, a constant patrol of Hellcats over the fleet, 24 hours a day. Radar picket destroyers were stationed far out to direct the fighters. The moment a raid was detected, the Hellcats were vectored in. These engagements were short, violent, and one-sided. The kamikaze Zeros were often weighed down by bombs, stripped of armor to save weight, and flown by pilots who had barely learned to take off. The Hellcats would swoop down, tearing through the formations. It was less like combat and more like a frantic race to destroy a machine before it could cause mass murder. Yet, the Zero proved resilient in this grim new role. Its lightweight construction, once a liability in a dogfight, meant it could glide for miles even with the engine shot out. Hellcat pilots reported shooting Zeros to pieces, watching parts fly off, seeing the plane engulfed in flames, yet it would continue its terminal dive, driven by the dying pilot's final act of will. It was a horror show. The skies over Okinawa and the Philippines were filled with the black puffs of flak and the burning streaks of falling Zeros. Despite the terror, the Hellcat held the line. The statistics from this period are staggering. During the battle for Okinawa alone, Hellcats and Corsairs intercepted thousands of kamikazes. If not for the Hellcat's ability to loiter for hours, its heavy firepower, and its rugged ability to fly through debris and flak, the losses to the U.S. Navy would have been catastrophic. The F6F had evolved from a hunter into a guardian. It was a thankless, grueling job, flying sortie after sortie until the pilots were exhausted, their nerves frayed. The kamikaze attacks represented the tragic end of the Zeros lineage. The aircraft that had once been the pinnacle of aviation engineering, the machine that had stunned the world with its agility, was now being used as a crude, disposable weapon. It was a humiliating end for a legendary fighter. Meanwhile, the Hellcat stood firm. It had proven it could defeat the Zero in a fair fight, and now it proved it could stop the Zero even when the rules of war were thrown out the window. The blue wall held, but the ocean floor was littered with the wreckage of both machines, a testament to the ferocity of the struggle. When the guns finally fell silent in August 1945, the smoke cleared to reveal a changed world. In the hangars of the victorious aircraft carriers and on the scrapped heaps of the defeated Japanese airfields, the two protagonists of the Pacific Air War sat silent. The Mitsubishi A6M Zero and the Grumman F6F Hellcat. Their duel was over, but the numbers told a story that would be studied for generations. The F6F Hellcat is officially credited with destroying 5,163 enemy aircraft in aerial combat. This accounts for 56% of all enemy naval aircraft destroyed by the U.S. Navy and Marines during the war. Its kill-to-loss ratio remains the stuff of legend, 19-1. For every Hellcat lost in aerial combat, 19 Japanese planes were shot down. It is a statistic of dominance that has rarely been equaled in the history of warfare. The Zero, which began the war with a ratio heavily in its favor, ended it as the most shot-down aircraft in the Pacific. But the legacy of these two machines goes beyond the scoreboard. The Zero remains a symbol of the Japanese spirit during the war, beautiful, dangerous, but ultimately brittle and unwilling to compromise. It reflected a mindset that valued the attack above all else, that saw protection as a weakness, and that believed spirit could overcome material superiority. Jiro Horikoshi's design was a masterpiece of aerodynamics, but it was a design stuck in 1940. It failed to evolve because the philosophy behind it refused to acknowledge the changing reality of industrial warfare. It was a sword, sharp, elegant, but easily shattered when it struck iron. The Hellcat, by contrast, was the embodiment of American industrial pragmatism. It wasn't the prettiest plane. It wasn't the fastest plane of the war. The P-51 Mustang and F-4U Corsair hold those titles. It didn't have the mystique of the Spitfire, but it was exactly what it needed to be. It was a tool designed for a specific job, to kill Zeros and bring its pilot home. It was the triumph of engineering over art, of durability over agility, of function over form. It proved that in a war of attrition, the machine that protects its pilot is the machine that wins. In the years following the war, the Hellcat quickly faded from service, replaced by the more advanced Bearcats and the incoming jet age. It didn't enjoy the long post-war career of the Corsair or the Mustang. It was a warhorse that did its job and was put out to pasture. Most were scrapped, their aluminum recycled into the booming post-war economy. Today, only a handful remain airworthy, appearing at airshows to the roar of their radial engines, a living echo of the battles they fought. The Zero, too, became a rarity. Most were destroyed by the Allies at the end of the war to prevent them from ever rising again. The few that survive are museum pieces, revered for their engineering and feared for their history. Standing in front of a preserved Zero today, one is struck by how small and fragile it looks compared to the bulky, imposing Hellcat often parked nearby. The story of the Zero and the Hellcat is the story of the Pacific War in microcosm. It is the story of how a technologically superior but resource-poor nation launched a surprise assault that stunned the world, only to be ground down by a nation that learned, adapted, and unleashed an industrial juggernaut. The Zero ruled the early skies, terrifying and invincible, a phantom that no one could touch. But the Hellcat was the answer. It was the machine that walked into the phantom's domain, took its best shot, and then shattered its legacy forever. The Hellcat didn't just win the dogfight, it cleared the skies for victory.